we're only going to deal with natural logs, so everything's going to be natural logs, okay? They are the same rules, but everything you'll see will be written as a natural log right now. Remember, natural logs are ln. Okay. Who, me? If you log the number 1, what do you get? And stumped. 0. Doesn't matter what the base is. It's always 0. If you are multiplying the arguments, that's the same as adding. If you are dividing, you are and if you have an exponent, yes, it drops down in front. All right. So he talked about what the natural log function is, right? Right? Okay. Thank you for placating me. Talked about derivatives. So if I said what's the derivative of the natural log of x? Yes. And if I said, what's the derivative of the natural log of u? And this is the one he talked about, I think, the formula. So if you're doing the derivative of a natural log, no matter what the function is, all you do is you go 1 over that function, so 1 over u, times the derivative of what that function is, the inside of it, so u prime, because it's chain rule, right? So this is the u primed over u thing, which is 1 over x. It's the same thing, because the derivative of x is 1, okay? This, you should remember that. So the straightforward examples are, if I say, what is the derivative of the natural log of 2x? I always use this formula, but I mean, the other one's the same thing. But essentially, you take what's inside the natural log, you put it in the denominator. What goes in the numerator? The derivative of 2x, which is? What happens to the 2's? And you're left with 1 over x. That is it. That's how you do natural log derivatives. Okay? So, no matter how complex the function, so I think he even showed you these things before. So what my function is, cos x goes in the denominator. What goes in the numerator? Derivative of cosine, which is negative sine. Which you could write as negative tan if you really wanted to, but you don't need to. That's it. That's how you do derivatives in natural logs. Okay? Now, you can couple it with a chain rule, product rule, all this type of stuff, though. So if we have y is equal to x natural log of x, what rule do I need to use here? Product rule. Product rule says, so yeah, so the derivative of the first one, which is 1, derivative of x is 1. So y prime is going to be 1 times the other function plus the derivative of natural log of x, which is 1 over x times the other function, which is x. So what's my answer? Out of x plus 1. Okay. So you can make your life easier too using the log rules. If I ask you for the derivative of x cubed, what can you do with an exponent in a log? You can bring it down. So this can be rewritten as, 3 natural log of x. Constants can be pulled out or you just kind of forget about them, right? Like you have to put them back in at the end, but you just have to look at natural log of x. What's the derivative of natural log of x? 1 over x, right? Does everybody agree with that? Times the 3, so I get 3 times 1 over x, or just 3 over x. What if I gave you this? Sorry? You can't take it out, but you can drop it down if you want. Is that what you mean? Okay. So I could rewrite it. Oh, that's a different type of question. You haven't gotten to those yet. There's a way you can do that. Like you can log both sides to drop it down. We're going to get to those in a sec. Okay. Natural log of e. Can somebody do that in their calculator? Yes. Why is it 1? Yes, because natural log is base e, right? Of e. When the bases match, it's just whatever the exponent is. In this case, it's 1, right? So you really are just deriving 2x. What's the derivative of 2x? 2. You could have done that from here and just gone straight to there. If you see natural log of e, you know the answer is just whatever that exponent is, and then just derive the exponent to get 2. Okay? All right, so where these really come in handy are when you have complex things. So we have so if that is my function, which is a gong show, okay, and I said, what's the derivative of that? Well, that is got product, quotient, and chain, well, it's got two chains actually, all munched together in there with a log, which is going to be a nightmare to do. It's going to be huge. It's going to get really ugly. But because it's being logged, that allows us to break it up. Because if you're logging two numbers that are being multiplied, that's the same as what? Adding. So we can rewrite this. So first of all, the top is being multiplied, right? So I can rewrite it as natural log of x plus natural log of x squared plus 1 all squared. And if you're dividing, you are subtracting. So I can subtract the bottom part here. And I'm going to write that with the exponent because we don't like radicals in calculus. Does everybody understand that step? This is important. This is like important. It's not calculus yet. It's math 12 essentially, but everybody understand how I got there? Okay. All right. Now we can make our life even easier because logs allows us to drop down exponents, right? So we can drop down the exponent. So the first one stays the same. The 2 drops down. And the 1/2 drops down. Now you're ready to derive it. So the derivative of a log is what over what? 1 over x or u primed over u, right? So the first one just becomes 1 over x. The second one, the 2 is a constant, so we just kind of pull it out and let it sit there. What's the derivative of natural log x squared plus what? 2x over x squared plus 1. Minus 1/2. What's the derivative of natural log 2x cubed minus 1? You're done. I mean, you can simplify this and clean it up, but I know. Logs actually make your life easier, which is something you probably wouldn't have said when you were in Math 12. So that is the answer. All right, because doing the derivative of a log is easy. It's u primed over u. All right, so when you get a nice, like if you were going to use product quotient on this, try it. Go home and try it. It's going to get crazy ugly. Chain. This is like, yes, you got to do a bit of work first, but as soon as you get to this point, it's like one line to do it. All right. Did he show you when you log both sides? Yeah, I won't worry about that then. Do you want me to start that? It's one more step. Let's just do it right now. It's one more step on this, and then this is the last question. He might show you on Monday. Sorry? It's 6 divided by 2, isn't it? Okay. So the other thing you can do, it's along these same lines, is if I have a function, any function, so 7. So we'll start with this thing. If I give you this, and you can do this on your final exam if you don't want to do it using product and chain and stuff. So if I gave you that function, I mean, that's pretty complicated. I wouldn't give you something this complicated. But say I gave you that function, and I said derive it. Okay, what rules are we going to need to use to do this? All of them. Because you've got quotient, so that's quotient rule there. You've got an exponent and a radical, so that means the power of a half, so that's chain rule. and these two bottom ones are being multiplied together, so it's a product. So it's a quotient rule with a chain product inside of it. That's going to get huge. But if you look at that and you go, okay, I don't want to deal with that, I'm going to log both sides, because what you do to one side, you have to do to the other side. So if I just natural log both sides, I'm going to write the square root as a power of a half. At some point, we're going to have to anyway. So I write it like that. That means I can, the right side, I'm going to now break up like we did in the previous one. So the top is going to become 2 minus all of the bottom. So once you do this enough, you'll be able to do it in one step. Does everybody understand how I got that? Okay, now we do the derivative. So, what's the derivative of natural log of y? This is the only trick. Sorry? Not 1 over y primed over y, right? Because we're going to go back here. The derivative of natural log of u is u primed over u, okay? So the derivative of the natural log of y becomes y primed over y. That's the only trick, but it'll always be that. Then you just do the derivative of all this stuff. So, what's the derivative of natural log x minus 2? That's exactly it. Times 2 minus, what's the derivative of natural log of x? 1 over x, right? Minus, because that negative goes there. What's the derivative of natural log x plus 1? Sorry? 1 over x plus 1. Okay, so then I get 2 over x minus 2, 3 over x minus 1 over 2 times x plus 1. Okay, we're not quite done yet. We're trying to find what? If I ask for the derivative. Y primed. How do I get y primed here? Multiply the y up. So then you get y prime is equal to y times this. What's y? So you just put that in front of all of this and you're done. So it looks ugly, but now you could find common denominators and combine it and do all that stuff, but we will not. Okay? Oh, that just becomes an algebra problem. So yes, the answer looks pretty gross, but imagine trying to do that with chain quotient product. That is going to be a nightmare. Okay? So yes, we log both sides, we break it up. The only trick is the derivative of natural log of y is y primed over y. Do the derivative of that side, multiply your y up, sub back in what y was, which is just the original equation, and you are done. Your homework questions, look, you've got a bazillion things to do, I know. But if you need to practice some of these at some point, 49, 73, not 173, and 89, 91, 93. Remember, you're only doing the odd ones.